Hello everybody, this is, I got the missed the intro, fantastic prompt format. I am Budrich and this is the fantastic prompt format. Alright, let's just delve into this, because there are so many things I want to show you in this video, or I would like to fit in this video. First, I should start by explaining or telling you that I have moved the code that we created in the last video into its separate file called new prompt. Let me just close the window here so neighbors doesn't have to listen to this. New prompt. And that file is located here in .bash inside the home directory, so I have it here. Maybe we should hide the video here, because I guess that's a bit distracting to look at Japanese 70s classic rock people standing on each other's shoulders while playing guitar. Okay, here we have the bash directory that I was talking about, and there we can see new prompt is one of the files here, which contains the prompt that we were doing, which we can see up here in the upper left corner here. And this terminal has my normal prompt, so I have this layout so we can compare them side by side and try to make our new prompt look like our old prompt, and eventually even replace the old prompt, because I have found some errors in the script. To do, decide what to print, S or milliseconds. Sub title ternary expressions. So decide what to print, seconds or milliseconds. No brainer, right? You know, if I do a normal command, it prints 042, meaning it took 42 milliseconds. But if the command takes longer than a second, then it prints the number of seconds instead. So sleep 2, then it will print 002. To do this, we have to test if the command is longer than 1 second or not. So let's do it the hard way first here. If S, and here, by the way, a couple of variables here. Also, it's very good to make sure that these variables are defined as local inside this prompt generator, so you don't set any stupid global variables here in bash or C unnecessary, whatever. And this, I have copy pasted this from the Stack Overflow thread there, but it's some fairly simple math that calculates the milliseconds and the seconds elapsed since the timer was last reset when the prompt generator is executed. So if we do a test here for S, which contains the number of seconds, integer, not floating point, so it's only whole number, so to speak. If that is greater than or equal to 1, then we want to print seconds. Then timestring is equal to $s, else timestring is equal to $ms for milliseconds. So this is the hard way to do it. Almost a bit stupid, but it works, and this is efficient. The thing I will show you is, I don't think it's faster, maybe slightly bit faster, probably a little bit faster, but it's nothing, it doesn't really matter, but it's a much cleaner syntax in one way. Because there are, 3 types of these tests you can write in bash, more or less. Or in one way, 4. The original classic way is to write it like this: test, if test, and test, there's an alias for test, and that's a single square bracket like this. And this is also known as like a POSIX test, because this is how you write in POSIX compliant shells like dash and such. And I think this would work. The reason I use double brackets all the time is because I just keep it as a habit to always use bash tests, because that's what I call these. They are exclusive to bash. And in this case here, it doesn't change anything of the inside of the brackets, but sometimes there are like minor differences on how you write it. I always mix it up in my head if I use these single brackets. There's not really any need except for the obvious one that it makes the scripts POSIX compliant by using them, which is kind of a very good thing to do, but I always write bash tests. But you can also do this, and I don't know, I think this is might also be bash exclusive. Maybe it is POSIX compliant. I'm actually not sure. If you have double parentheses instead of double square brackets, that means you are now doing an arithmetic test. And now this GE flag here doesn't work. Now you write it like normal math test. So if s is greater than or equal to 1, this means the same thing. And in my opinion, this is the cleanest one to do when you are doing pure mathematical tests. And I also think it's faster, but I'm not 100% sure about that. With that out of the way, you can also do this. Let's show it here. Echo. If we print this test, well, let's say s is 20 is greater than or equal to 1. And here I'm doing an echo. So now it will echo the result of this. What will that be? 1. Because 20 is larger or equal to 1. If we would do 30 here, is 20 larger than or equal to 30? No, it's less than 30. And then you get a 0. You get a Boolean value, 1 or a 0. A binary value. And you can also, instead of writing a test, you could actually do some math here. So 20 plus 5, then it will print 25. The ternary expression, it looks like this. So if 20 is larger than or equal to 30. This is just a stupid demo test here, so don't worry about this stupid question that I'm asking here. 20 larger than 30, of course it isn't, but you can write it like this. If you have a question mark after with this one, that means if this test is true, then this will be the output of this thing. So the output could be 555 if 20 is larger than or equal to 30. And you also need an else case. It's not really exactly an else, but almost the same thing. Else 999. So now if we do this, echo, it will print 999 because that is because 20 is not larger than 30, so it will take this else thing. And really short here, just a demo, is that you can even ask more questions, as many as you want in these ternary expressions. But I warn you, try not to ask too many questions. It gets really hard to read the syntax. There are some cool ways you can format a program with these, so it's more usable, but try not to overuse it. It's good when it's just an if-else, or maybe 3. So you could do something like this. So 20 is larger than 30, if that is true, 555, else 20 is less than or equal to 25. Question mark. Now it tests for this test instead, and then we could print 444, but if that is also false, print 999. Or we could continue here with more tests, and you can add tests at these locations also. So as you can see, it's kind of hard to read these things when you see them directly in a program, but if you are careful when you're formatting the lines, it will be fine. And now we can see we get 444 because 20 is not larger than 30. So this, it never does this thing, but then it goes after the colon here and it's a new test. 20 is less than or equal to 25. That's true. So it 444 will be the output of this. And this means that we could set timestring here to be equal to this test here, and then use the ternary expression here. So if s is greater than or equal to 1, then timestring is seconds, else it's milliseconds. So this is how compact you can write this if-else thing when you're just dealing with math, because that's important. This only works with math and the integer numbers, not floating point numbers, so it's kind of limited, but when you can use them, it's really nice to be able to do so. And then we replace this ms here with timestring, and we should also add timestring as a local variable here in our function, so we don't create stupid global functions as I just mentioned. Reload bash rc. We will not see any difference here because now sleep will also print 2. Okay, we're done with this part. Format the timestring so it prints 3 characters, because that's what we have in our other terminal here. You see I have always pad the number with zeros if the number is less than 2 characters long. So that's very easy to do. You can just use printf %d stands for digit, or which have to be an integer, which it is here now. It's always integers, and then an actual integer here, 1 2 3. We should add a new line here. This will just print 1 2 3. But here you can add some options to the digit here. So if we want it to be 4 characters long, for instance, then we do this, and now you can see the string is 4 characters long. Maybe it's not super visible, we can make it much longer, like 8. Now this is 8 characters long. If we want to pad it with zeros, we enter 0 8 here, and now we get this. So that's how we will do this, and we could just add the output of a printf here. Printf %03d timestring, and now if I reload the shell here, now we got a 3-digit number here. Alright, we get, let's test it with time just so we know that we aren't losing. Now you can see we got 39 milliseconds here and 37 here. So it's not, I mentioned it in the last video, it's not perfect, but it's sure is good enough. And I don't think I have ever seen an error that's bigger than 5, probably not even 4. It's usually exact or just a millisecond or 2 away from the actual value, whatever. And you can see we are very closer to this prompt. Maybe we should tidy it up here so we get even more similarities. Let's remove these dashes and only keep one of these angle brackets. And now it's really can almost not tell them apart. But things get different here now when we get to this last chunk of the to-do list. Create a short version of the path. And to do so, we will modify or use the string PWD, because now we are using \w here, which prints the home directory here. So if I would enter .config/i3, now we can see it says so in the prompt here. But if we would enter the same directory in with this prompt, we just get the C and I here, and this is what I like to have for reasons. And we cannot use, there is no backslash thing to get this format of a path. We have to create it ourselves. I think I want to show you here in the prompt again. I think it's a good way to demo things. You know, we got the echo PWD that will print the current working directory, the full path without tilde or anything. What we want now is we want only the first character of each subdirectory in the path. So how would we do this? Let's go here, because I want to use this as the demo directory, because it's very good since it's very bad. And what I mean by that is, here you can see this directory. It starts with a dot and it have spaces in the path name and stuff. So that's a very good directory to test that everything here is working. And if I want to print the first character of each directory here, we could try to loop for directory in PWD, do echo D done. What do we get now? We get blank home bud. This I probably didn't reset OFS, because that was the right. IFS is equal to OFS. I will show you this soon what this is. So there. God damn it. No, this is what I wanted. Whatever, I will explain this IFS stuff, because that's important here when we are doing this. So when we do a loop on the working directory here, and echo each D, which is each element of the loop, we get this output. First element is this /moon/bud.moonchild. Second element, productions/pale. Last element, moon. Because, you know, it's Bash by default, it splits on white space. It splits on space, which we have here. It splits on new lines, and it splits on tabs. And these splits are defined inside this environment variable called IFS. If you unset IFS, then it will revert to the default, which is space, tab, and new line. But we can modify this internal file, or set this IFS to whatever we want. And the obvious thing to do when you're looping a path like this is to set it to a /, because that's that is the field separator in a path. And it's not allowed to have / in the path name itself. It's a forbidden character in directories and files. I think it is it have to be, right? And if it isn't, those who are putting / in a directory name are not friends of mine. So it will never happen to me. But I think it's not allowed to have it. You will get an error. Maybe we can try it. Make deed home. Or let's do this. Home / escape / Arno. Oh, no, we're not allowed to do that. So whatever, sidetrack, sorry for that. Let's set the IFS to a forward slash. IFS is equal to forward slash. But when you're changing the IFS, the internal field separator, it's a very good idea, just to be safe, to make a backup of the current value. So I like to do this. OFS, original field separator, is equal to IFS, and then we can set IFS is equal to forward slash. And now when we execute the loop, we can see that each directory is printed on its own as an own element, and we also get this blank element, the first one, because the first element is blank. Okay, this is what we need. But now we also wanted to only print the first character of each directory. We can do this by using substrings, you know. I think I've shown you this a couple of times before, but if you use this variable expansion, variable colon, and then start at the first character, which is 0, and print a 1 character long string created. So this will look like this. Now we only get the first character. And if we would change this to 0:3, we will get a 3 character long string, if it's possible. And it is. We get this. And if we would change, of course, let's do 3 again, but then we change this to 1, then it will start at the second character of each element. And what we want to do is print every non-dot character. So 0, 1. So if this is equal to a dot, then we print this instead, the second character. Let's copy this loop here. And also IFS is equal to backslash. So there are two ways to reset the IFS. Either unset the IFS variable and then it will revert back to the system defaults, or you create a backup and set it back to the backup again, which is the best way in my opinion, because sometimes I change the IFS actually, and it doesn't have to be the default system default that I want. So this is safer. Okay. And now we don't want to echo anything here. We want to do a couple of things. Let's start by this. Let's create a couple of more local variables here. One that we can call pathstring and one that we can call dirchar. And dirchar is the character here that we want to add to our pathstring, which is this. Then we test if dirchar is equal to a dot. Then we set it to the second character instead of the first. This, and then when we got a dirchar, we just append that to this new variable that we call pathstring plus equal. Let's do this. Dirchar. Okay. And last but not least, we replace this W with our new pathstring variable. What's up? Don't need any quotes. There we have quotes here. Okay, shell reload, oops, like that. And now we get this string, HBMP. That doesn't look right, or does it? PWD HOME HB Bud M Moonchild Productions P Pale Moon. So it is the right characters at least, but one thing, I want to replace these two with a tilde. So the home character or the home directory should be printed as a tilde. And we want a slash between each directory. To add the slash, that's really easy. We just add a / here before we append the dirchar to our path string, and now it looks like this. Problem here though, as I mentioned, the first element is blank, so then it would just append a slash and no character. We really don't want that. So a good thing here to do is to test that D has a value at all. If it doesn't, if it's empty, C, then continue. This, and now we should get rid of that double slash. Yes, okay, now we want to replace this H and B with the tilde, and I don't know, I think this, we do it like this. We remove the home directory from PWD here, from the beginning of PWD like this. So now we should get something that looks like this, MP. So now we only get Moonchild Productions. And then we add the tilde after the loop. We could do it before also, it doesn't really, maybe it makes more sense to do it here. Because if PWD starts with home, then path string is equal to tilde. And there, now it prints, because now it sees here, PWD, it starts with, I do a regular expression here, a simple one, to test if the current working directory starts with the home directory. If it does, then it will initiate this variable, create this variable called pathstring and set it to just a tilde. And then we append stuff after this tilde in the loop here. But if the working directory doesn't start with the home directory, for instance, if we are in etc x11, what do we have here? Xinit, we are here. Oh, we need the CD. What happened now? God damn it. No idea what happened. Yeah, now we are not in the home directory. We are in root etc, and then we don't get the tilde at the beginning of the string. So this is what I wanted and where the goal of this video. And now we can compare it here with our other string here. Let's go back to that Moonchild productions directory. We can see tilde MP. If I go to this directory here in my old prompt, home.moonchild pale moon, you will see that I had an error in my script here. So here I actually did split on space, so I get a 4 element long, and this is really bad. And I didn't know this. I don't know how I could have missed it, but it's one of the first bash scripts I did, this prompt script actually. So I did it completely wrong there in my old prompt script here, and didn't care about and I also make some weird, first create an array and actually add more spaces and then loop the array. So stupid. It's much better this new way here. Yeah, other than that error in this, the only difference now is that we got some nice colors. I don't know how visible they are, but there are colors in this prompt and not in this one. And I changed the color of the time depending on how long it takes. So I think we look into that in the next video. Thank you for watching, everybody. Have a great day. Bye.